In this video, you will learn about the confusion matrix, a representation of a classification model's performance. Let's jump in. Take a look at the example classification model that predicts customer satisfaction for a fictitious airline using the logistic regression algorithm. The predictor columns contain passenger and flight information such as customer type, type of travel, flight distance, and seat comfort. The target column is called satisfaction and has two classes, satisfied and dissatisfied. The score JavaScript node reports the performance of the classification model in its interactive view. Here you see the confusion matrix reporting its performance. Our example is binomial classification problem, so the confusion matrix is a 2x2 matrix. The actual target classes define the row IDs, and the predicted target classes define the column headers. First, we determine one of the target classes as a positive class and the other as a negative class. This assignment is arbitrary, but often the positive class refers to the class of interest. In our case, we assign satisfied as a positive class and dissatisfied as a negative class. The confusion matrix reports the four counts, true positives, displayed in the top left cell. These are customers who were actually satisfied and correctly classified as such. False negatives, displayed in the top right cell. These are customers who were actually satisfied but incorrectly classified as dissatisfied. False positives, displayed in the bottom left cell. These are customers who were actually dissatisfied but incorrectly classified as satisfied. True negatives, displayed in the bottom right cell. These are customers who were actually dissatisfied and correctly classified as such. To summarize, positive or negative refers to the predicted class, while true or false indicates whether the prediction is correct or incorrect. Correct predictions are on the diagonal, and incorrect predictions are on the anti-diagonal. The confusion matrix can also evaluate the performance of a multinomial classification model. For instance, if you have three target classes, the matrix becomes a 3x3 matrix. In this example, the target column satisfaction has three classes, satisfied, dissatisfied, and neutral. You define satisfied as a positive class, while neutral and dissatisfied together define the negative class. In this video, you have learned how to use the confusion matrix to evaluate the performance of a classification model. Interpret the four counts, true positives, false positives, true negatives, and false negatives. Apply the confusion matrix to both binomial and multinomial classification models. The confusion matrix is a powerful tool for understanding the accuracy of your classification models, helping you to identify both correct and incorrect predictions effectively.